So one of the ways that waves can bend is reflection. Reflection is when a wave bounces off of an object. You've seen reflections before in mirrors, in ponds, in soap bubbles, in windows. Reflection is very, very common with light, and we're quite familiar with it. Reflection with sound is called an echo, and you're familiar with those too. So reflection is a very, very common thing that waves do. Not only waves do it, any object can reflect. And there's something you should notice about these reflections. When it comes in at a high angle, it comes off at a high angle. When it goes in at a low angle, it comes off at a low angle. So the law of reflection says that the angle of incidence, that's the incoming angle, is equal to the angle of reflection. It leads to a very boring equation. Angle of incidence equals angle of reflection. Those are always measured with respect to the normal, with respect to the perpendicular line. And so you might get tricked on a problem where it might say something like this. What is the angle of reflection of this object? And it's not 30 degrees, it's 60 degrees because of where the angle is measured from. So be careful on that. Always measured with respect to the normal. Now, waves follow the law of reflection, but they don't always look like they do. For one example, if you're looking at, say, the chalkboard behind me, the light that comes in and hits that chalkboard doesn't appear to be bouncing off in one direction. If I shine a flashlight on it, then that flashlight is going to spray in all directions. So this is known as diffuse reflection, and it's because if you zoom way in, even on relatively smooth surfaces like a chalkboard, you will find that they are really rough and craggy on a very small scale. And so every little beam of light that hits follows the law of reflection, but when they all do, they end up hitting things with different normals, and so they reflect off in all sorts of different ways. When you have a very smooth surface like a mirror, we have what's called specular reflection, which is a vocabulary word you will probably never hear again unless you go study optics. I'm not going to test you on it. That's regular reflection, as it were, even though it's less common than diffuse reflection. Some things appear to violate the law of reflection in other ways. Like, so for example, when you have something retroreflective, like a road sign, why is this sign so bright? And it's because more of your headlights are coming back straight at you than hitting and spraying away. And it appears to violate the law of reflection. Retro means backwards, so it comes in and hits and comes straight back. Well, if we zoom way in and look at it, it's really not that big of a deal. So what you have a lot of the time is something like little dag teeth. It looks like battlements on an old castle. And when the light comes in straight, about half of it reflects away following the law of reflection off the top surface. But the rest of it goes into those little nooks and crannies and reflects around inside, but when they come back out, end up coming straight back at you. This is only one type of retroreflection. There are several others, but that's just an illustration of how something that seems to violate the law of reflection is actually just some clever technology taking advantage of the law of reflection. Have you ever wondered why mirrors flip things horizontally but not vertically? Well, Physics Girl explains it a lot better than I ever could, so check out this video. I'll put it down below in the comments too. It's definitely worth the watch.